Efficient Solar for the Red Rocks 2020 Expo.
There are an average of 25 electronic devices in each American household. The energy to power these devices must come from somewhere, that being predominantly coal burning and the burning of other fossil fuels. These energy sources are polluting the air. The Environmental Protection Agency recorded 15% more days with unhealthy air in the country in 2018 and 2017 compared to the average from 2013 to 2016. Air pollution is a mix of particles and gases that can reach harmful concentrations both outside and indoors. Its effects can range from higher disease risks to rising temperatures. Some of the more common air pollutants include soot, smoke, mold, methane, and carbon dioxide. So, there are many health risks associated with pollution. One measure of pollution is the Air Quality Index, which measures the air conditions of the country based on concentrations of the five main pollutants: ground level ozone, particle pollution, carbon monoxide, sulfur dioxide, and nitrogen dioxide. The high levels of these pollutants are linked to an estimated 4.2 million premature deaths in 2016, with about 20 of these deaths occurring in highly polluted third world countries such as India and China. In the US, nearly 134 million people, over 40% of the population, are at risk of disease and premature death because of air pollution, according to the American Lung Association's estimates. The burning of fossil fuels such as gasoline and natural gas are among the most common of greenhouse gases, which trap heat and pollutants inside the Earth's atmosphere, raising the overall temperature of the Earth and damaging ecosystems. Humans have expelled enough carbon dioxide into the atmosphere over the past 150 years to raise its levels higher than they ever have been in the hundreds of thousands of years. The way we create and sustain energy needs to change before there is an even more detrimental impact on the environment and the health of people everywhere on Earth. Solar power is arguably the cleanest, most reliable form of clean energy available. It can be used to power homes and businesses, reducing a large portion of greenhouse gases emitted into the air. The greenhouse gases levels emitted by solar panels is almost zero. It uses power from the sun to create energy, which is an infinitely renewable source that we can depend on. Solar panels are also extremely cost effective. On average, a solar panel system pays for itself within 8 years. If a consumer purchased mono or poly panels with a 25-year lifespan, consumers could yield 17 years of cost savings on electric expenses. The Sunshot Vision Study provides a thorough assessment of the potential for solar technologies to meet a significant share of electricity demand in the United States over the next several decades. Using solar energy significantly reduces greenhouse gas emissions, air pollution emissions, and reduces water use. Achieving the sunshot scenario reduces greenhouse gas emissions from the power sector by 13% in 2030 and 18% in 2050. It also reduces emissions of sulfur dioxide, nitrogen oxides, and fine particulate matter in the power sector by 14%, and 13% in 2030, and 15%, 18%, and 13% in 2050. The Sunshot Study scenario also reduces power sector water withdrawals by 8% in 2030 and 5% in 2050.
There are many possible solutions for pollution. As described in the PBS documentary Power Surge, the pollution wedge theory describes that increase in efficiency and increase in the ability to gather solar energy are just two of the minor fractions to solve this problem. But how about combining these two to harness as much energy through solar by being the most efficiently? Let's test a problem where we know how to gather energy, but how do we make it more efficient? In our solar experiment for this project, we are going to discuss the following questions. What angle should the solar panel be at to produce the most energy possible? How much energy can the sun produce versus a light bulb? And what is the efficiency drop-off rate per 10 degrees off that ideal angle? For this experiment, we use the following equipment: a solar panel, a multimeter reading in volts, and a device to read the angle of the solar panel. This device is homemade. We use a protractor on the end that has a rotating flat surface that we use to measure what angle it was from parallel to the Earth. First thing we had to do for this experiment was to calculate the sun's position in the sky using the solar position calculator that was provided from noaa.gov. When we calculated the sun position for the given day and a given time, we were able to calculate that the sun's position in the sky was 48.5 degrees when we executed this experiment. To collect this data, starting at 180 degrees parallel to Earth, we rotated the solar panel 10 degrees off perpendicularity towards the sun and recorded the number that was read on the multi-reader in volts. We did this process twice, and then we took the average of the two numbers. Shown here is the data we collected from the multi-reader in volts. Every 10 degrees we recorded the number twice and then got the average. This confirms that the sun was 48.5 degrees in the sky that day, with our most efficient readings being between 30 and 50 degrees. Shown here is the data we collected from the multi-reader in volts with the lamp directly above the solar panel. We noticed that the most efficient solar panel reading is when the solar panel was directly perpendicular to the lamp. We then rotated the solar panel 10 degrees and noticed the efficiency drop-off rating increase per 10 degrees. From our results, we know the most efficient angle is perpendicular to the light source. The sun produced 77% more power on the solar panel versus the light bulb. The sun saw initial 0.4% efficiency drop-off rating for the first 10 degrees off perpendicularity, and up to 3% around 40 degrees from perpendicularity. Now this was during midday. The light bulb, which was directly above the solar panel, saw a 30% drop-off rating for the first 40 degrees off perpendicularity, and up to 94% when 90 degrees off perpendicularity. In conclusion from our experiment, the sun produces better energy during midday when the UV is so concentrated that you will not really see efficiency loss per degree off of perpendicularity. Though, if the sky was overcast or cloudy that day, the efficiency drop-off rate per degree would be more visible. So what can we do to be more efficient with solar panels? One of the newer technologies that has been released for solar panels is solar trackers. This helps you increase your efficiency rating by tracking the sun's position in the sky, or by generally knowing where you are and what climate you're in to have your solar panel automatically pivot to get the most efficient electricity gathered. Some other pros would be that this is still a really growing technology, so there is continuously newer and newer research being done, and most grad students are actually using this as one of their thesis designs and trying to improve solar tracking. Some of the cons to this, though, is that higher initial investment up front will take longer to pay off in the long run, and with all these more moving parts and pistons, there is more maintenance that needs to be done over time. So how do solar panels work? Well, solar panels are made of arrays of solar cells, which are just semiconductors of photovoltaic effects or photovoltaic energy that can be converted from sunlight into electricity, which is going to be a DC current. Now we don't use DC current, so it's got to be converted by a solar inverter to AC electricity. Once it's converted to AC, we can then either use it right away or store it. Thank you for watching this. Let's use the information that we have gathered to be more efficient and to produce as much pollution-free energy as possible to make the world a better place.